Hello, my dear boys. Welcome all of you to my online class. This is your physics class. Today we will discuss on chapter 7. The name of our chapter is waves and waves and sound. And today's our topics is necessary equations for solving the mathematical problem, and then we will discuss some sample mathematical problem on this chapter. Okay, let's start our class. Okay, now first topics necessary equations. Our first topic is necessary equation on this chapter. Equations. From this chapter, the first equation we will get from this chapter is f equal to minus kx. Here f is applied force, f is applied force, and the unit of force is Newton, and k is called spring constant, and the unit of spring constant is Newton per meter, and x is position, and the unit of position it is distance, so the unit of position is meter. Number 2 equation is t equal to twice pi root of k by m. Here t is denoted as time period. Time period. The unit of time period is a time, so unit of time period is second. SI unit is second. Here k is mentioned in our previous topics, so m is the mass. So the SI unit of mass is kg. Okay, the SI unit of mass is kg. Then our third equation is equation number 3. Here also t equal to twice pi root of L by G. Here t is time period unit second. L is length of the string, length of the string, and the length of the string, the unit of length of the string is also meter, and here g is the gravitational acceleration, Leration, and the unit of gravitational acceleration is meter per second square. Now the term time period, what is called time period? Now our question is what is called time period? What is called time period? Okay, then the answer is time required for one complete vibration, of a wave transmitting particle is known as time period. Okay, the time required for one complete vibration of a wave transmitting particle is known as time period. Okay, then our next equation is the very well-known equation number 4. Equation number 4 is the relation among wave velocity, frequency and wavelength is V equal to F lambda. Here V is called wave velocity and the unit of wave velocity is meter per second. The lambda is F is called frequency and the unit of frequency is hertz or cycle per second or only per second. You have to know all these 3 units for MCQ. Okay, and here lambda, the symbol is called lambda. Okay, lambda is denoted for wavelength. And the wavelength is also a distance, so unit of wavelength is meter. Okay, now I will discuss what is called wave velocity, what is called frequency and what is called wavelength. This is a very important type necessary equation. Okay, so we will discuss what is called wave velocity, what is called frequency and what is called wavelength. So our first topic is wave velocity. So what is called wave velocity? Wave velocity is the distance traveled by a wave in a certain direction in 1 second is called wave velocity. Okay, the wave velocity is the distance traveled by a wave in a certain direction, not in different direction, in a certain direction in 1 second is called wave velocity. This is very important type for knowledge based question. Okay, what is called wave velocity? Okay, the distance traveled by a wave in a certain direction is in 1 second is called wave velocity. Okay, answer. Next, our next definition is frequency. Frequency. What is called frequency? Frequency. What is called frequency? The number of complete waves produced in 1 second is called frequency of the wave, and the frequency is denoted by f. It is denoted by f, and the unit of frequency is we know that hertz or cycle per second or per second. Okay, the number of complete waves produced in 1 second is called frequency of the wave. It is denoted by f, and the unit of frequency is hertz or cycle per second or only per second. You have to know all of these three units for MCQ. Okay, then our next definition is wavelength. What is called wavelength? This all of these are very important for knowledge based question. Okay, now our definition is what is called wavelength. So wavelength, what is called wavelength? The distance between two successive crest or troughs of a wave and is measured in the direction of the wave is called wavelength. The wavelength is denoted by lambda, and unit is meter. Okay, the distance between two successive crests or troughs of a wave and is measured in the direction of the wave is called wavelength. Okay, it is denoted by lambda as we mentioned before, and the unit of this wavelength is meter. Okay, now the equation number 5 is it is also very important equation. The equation number 5 is V is proportional to root over t, square root of t. Here V is wave velocity, and here T is temperature, absolute temperature. And the unit of this absolute temperature is Kelvin. If we have given in degree Celsius, then we need to convert it as Kelvin temperature, because we know that the Kelvin temperature is our SI unit. The Kelvin is our SI unit for temperature. Okay. Now our another important equation, equation number 6 is T equal to 1 by F. Here T is not temperature, here T is time period and F is frequency. So time period is directly proportional, inversely proportional to the frequency of the wave. Time period is inversely proportional to the frequency of the wave. Okay, here T is not temperature, T is time period, and F is called frequency. Okay, and now the last equation, this is also very important equation. This equation comes for echo. Okay, we know the echo, the reflection of sound is known as echo. Okay, so we know that for echo the distance will be d equal to Vt divided by 2. The distance will be d equal to Vt divided by 2, or we can write it as S equal to Vt by 2. Here d or S equal to distance between source and the listener. Distance between source and the listener. Okay, and this is the unit of this d is also meter, because it is the also a distance. Okay, so this is our necessary equation to solving the problem on this chapter. So let's see some simple mathematical problem on this chapter using these equations. Okay, then our first mathematics is so sample problem. Okay, so our sample problem is: in summer the velocity of sound is increased by 0.5% in a town. If the temperature in water is 10 degree, what if the temperature in winter is 10 degree, what is the temperature in summer? This is our sample problem. Okay, in summer the velocity of sound is increased by 0.5% in a town. If the temperature in winter is 10 degrees Celsius, what is the temperature in summer? This is our sample problem. Here we see that we have given that the winter, the temperature of winter and the velocity of sound is increased by 0.5% in summers. Okay, so we need to determine the temperature in summer. Okay, so we can write, we have given that temperature of temperature of winter T1 equal to 10 degrees Celsius. So we need to convert it as Kelvin temperature. So 10 plus 273 equal to Kelvin. So we can write 283 Kelvin. Let the velocity of sound in winter is V. Velocity of sound in winter V1 equal to V, and we have given that the velocity of sound in summer will increase by 0.5%. So we can write the velocity of sound in summer V2 equal to V. Velocity of sound in winter plus increased by 0.5%. So we can write V of 0.5%. For 0.5% we can write 5 by 100. Okay. By calculating, we will get 1.0005 okay, this is our V. Okay. Oh, sorry, 0.05. Okay, so 0.05 divided by 0.5%, so 0.05%. So the velocity of sound in summer will be V2 equal to the velocity of winter V plus we, according to our question, the velocity of summer will increase by 0.5%, so we can write V into 0.5 divided by 100. By calculating, we get 1.005 V. Okay, and the velocity of summer T2 equal to what? So we will use what equation? Okay, to solving this mathematical problem, we need to the equation for relation between velocity and temperature, and we know that the relation between them is V is proportional to T. So we can write we know V1 by V2 equal to root of T1 by T2. Okay, so we can write T2 by T1 equal to V2 by V1 square, or T2 equal to V2 by V1 whole square into T1. Okay, then putting the value of velocity and temperature, we can write T2 equal to 1.005 V divided by V whole square into 283. Okay, then by calculating we get 285.84 Kelvin. So in our question we have given in degrees Celsius unit, so again we need to convert it by degrees Celsius unit. So T2 equal to 285.84 minus 273 Kelvin. Our answer is 12.834. Okay, or we can write 84. Okay, that's for Kelvin. So the temperature in summer is 12.84 Kelvin. This is our answer. So in our next class we will discuss on creative question from this chapter. So until then, thank you boys.